This week we begin our last very short unit, which is on trade and globalization. So on this first day, we're just going to look at a few concepts related to trade, absolute and comparative advantage, the concept of autarky, factor endowments, and how to calculate terms of trade. So first of all, there's two concepts when it comes to advantage in trade. There's absolute advantage and comparative advantage. And what most people think of automatically is this concept of absolute advantage. So we're going to talk about that and dispense with it first, and then we'll focus on comparative advantage. So absolute advantage is when you can actually produce more of a good or service than someone else, given the same amount of time. And they often say given the same amount of resources, but of course countries don't have the same amount of resources. So Saudi Arabia has an absolute advantage in oil production, which means they can produce more oil than other countries. Michael Jordan once had an absolute advantage in basketball. He could score more points than other players. So if you look at this table here, let me scroll down, you can see, okay, these are, PPC data, basically, and you want to look at who has an absolute advantage in avocados. Is it the United States or is it Mexico? And so the only question is, if they put all of their resources into producing that good, how many avocados could they produce? And if you look at this, we want to go with Mexico because we know avocados come from Mexico, plus we see that 60 is shaded. But if you actually read the numbers, you'll see that if the U.S. really tried, right, we could produce more. So we have an absolute advantage in avocados. We can produce more. If you look at soybeans, same thing. We can produce 30, right, and Mexico can produce 15. We have an absolute advantage in both things. And so some might look at that and conclude, oh, well, why should the two countries trade? We can produce more of both. But remember, every time we produce an avocado, we're actually giving up soybeans. And every time we produce soybeans, we're giving up avocados. So there's actually an opportunity cost. We can't actually produce 90 avocados and 30 soybeans, right? We have to give up something when we produce something. So comparative advantage focuses on this, the ability to produce something at a lower opportunity cost than another person, than another country, given the same time frame. So, for example, China has a comparative advantage in textile production. We might, in fact, be able to produce more t-shirts than China if we really tried, but they can do so at a lower opportunity cost. So when we look at opportunity cost, that changes this. Who has the comparative advantage in soybean or avocado production? Well, now we have to actually calculate opportunity costs. So if Mexico specializes in producing soybeans, if they produce 15 units of soybeans, they have to give up 60, right, units of avocados to get the 15. And we're just going back and doing opportunity costs like we did a long time ago. Right, so their opportunity cost for soybeans is 4. Their opportunity cost for avocados is the opposite, right? It's 15 over 60, or 1/4. All right, so what about the U.S.? In the U.S., if we focus on producing avocados, we have to give up 30 units of soybeans to get those 90, right, which is 1/3. Our opportunity cost of producing avocados is actually higher than Mexico's. Okay, they have a lower opportunity cost, so they're actually going to have a comparative advantage here. And here, of course, their number is going to be 3. So our number is going to be 3. We have a lower opportunity cost in soybeans. So we should produce the soybeans, we should let Mexico produce the avocados, and then we should exchange. So to determine comparative advantage, you want to look at the numbers in the grid, and you want to understand what they mean. So the numbers in the grid are going to represent the units of resources used. Then it's an input problem, and your goal would be to minimize them. If the numbers in the grid represent the units produced, then it's an output problem, and our goal is to maximize output. So what we just looked at, right, we didn't really have a grid here. I'll show you some problems with grids. What we had here was the entire PPCs for both countries. But what we're going to do when we do comparative advantage problems is we're going to simplify that, and we're going to have a little grid that's going to be like U.S. and Mexico, avocados, soybeans, okay, and we're just going to take the data from the extremes here. Okay, so U.S. 90 avocados, 30 soybeans, Mexico 60, right, and 15, and we're going to calculate the opportunity cost using those extreme case numbers. So if you look at these problems, for example, Anna and Barry, potatoes and cabbage, if you're given a grid like this, you have to understand what do those numbers mean. So if what it means is Anna can produce either 100 units of potatoes or 200 units of cabbage, Barry 120 units of potatoes, 150 units of cabbage, then that's an output problem. An input problem would be like, in order to produce 1 unit of potatoes, it takes Anna 100 acres. Okay, but it takes Barry 100 acres. So if that makes sense, you want to look at what does it mean? Does it mean the number of units of output or the number of units of input? So once we decide which kind of problem it is, there's actually a really easy shortcut for solving comparative advantage problems. So if we've decided that this is an output problem because it's actually bushels of potatoes or bushels of cabbage, then we want to maximize the output. There's 2 possible combinations. There's Anna produces potatoes and Barry produces cabbage, and there's the other combination, which is Barry produces potatoes and Anna produces cabbage. And the shortcut here is that you can simply cross multiply. So you take this 100 times 150, right, and you get 15,000, unless my math is really messed up. Okay, and you take 200 times 120, and you get 24,000, right? And you see that 24,000 is larger than 15,000, so this is actually the right combination. If it's an input problem, you're going to follow the same process, but you're looking for the lower number combination. So let's do one more example here. Let's look at Henry and John with deer and antelope, and imagine this is hours, okay, how many hours it takes them to kill 1 deer or 1 antelope. So we want to look for the fewest number of hours used, right? So if you know this is hours, you might even want to write this in here, right, to remind yourself, you know it's an input problem. We want the lowest combination. So 4 times 12 is 48, and 24 times 6 is, I don't know what it is, 144, something like that. Okay, so we definitely want the lower combination. So Henry should be the one going deer hunting, and John should be hunting antelope. So if you have questions about that, we can talk about that at the next meeting. There's a few more practice questions on here, which I would definitely encourage you to do on your own and bring those to get them checked. You can decide whether you want them to be input or output problems. Totally up to you. Okay, so David Ricardo developed this theory based on comparative advantage that if nations specialize in producing the goods and services for which they have a comparative advantage and trade for the others, the total production of goods and services will increase. And people in both nations, or really all nations, will benefit. Why? Because nations produce what they can produce at the lowest cost. Because nations focus on the things for which they have a resource endowment. So if you have a lot of good land for growing corn, you grow corn. As nations specialize, they get better. So you get better at the things you do, rather than just trying to do everything and not really getting good at anything. Resources get put to their allocatively efficient use or their greatest value purpose internationally. More gets produced, prices drop, and standards of living globally improve. Okay, so why do we produce wheat, and why does Saudi Arabia produce oil? Well, we talked about advantages, right? And part of the reason is because different nations have different factor endowments. So we have a lot of oil, but we don't have as much oil as Saudi Arabia, right? And Saudi Arabia doesn't have as much arable land as we do. So just want to understand that term, factor endowment, and what it means. But more is not always better. There's something called the paradox of plenty, or the resource curse, which comes up a fair amount actually in Econ Challenge, and that is this concept that having a lot can actually make you lazy, and you might actually end up doing less. And so there are places, for example, in the Middle East, also Russia would be a good example, when there's a lot of resources, and what's happened is that rather than developing the economy, developing human capital, and improving a diversified economy, the government just seizes the profits from the valuable natural resources and lets the people live in poverty. Okay, terms of trade. Once you've decided that 2 nations are going to trade, you can calculate the opportunity costs in each nation to figure out what is a fair term of trade. So for example, let's say we have a comparative advantage problem, and we have determined, based on the numbers in the grid, that the opportunity cost for a ton of wheat in the US is half a bolt of cloth, and the opportunity cost for a ton of wheat in Canada is 3/4 of a bolt of cloth. In order to figure out terms of trade that both countries would agree to, you have to come up with common denominators. So we change the half and 3/4 to be 4/8 and 6/8, and then you just look for a number in between. So 5/8 is in between. That means 5/8, trading 1 ton of wheat for 5/8 of a bolt of cloth, is actually favorable to both countries. So you probably don't have to do this a lot, but I just wanted you to see that in case it does come up. Another way to do it, and we don't really do this very much, is you can actually plot the various points, the various combinations that are available to a country like this. Okay, and this is the marginal rate of transformation. So you can see in the United States, one possibility is, 2 wheat and 1 cloth. Another is 4 wheat and 2 cloth. You plot that for the U.S. and for Canada, and any combination in between is going to be acceptable. So the higher the numbers that you use, the 8 to 4 and 8 to 6, right? You get in here, you're going to find more possible numbers that work, whereas at lower numbers, you're not going to find very many. Okay, autarky. The term autarky just means self-sufficiency in the production of a good. So if you see the word autarky, it means that a country is closed to trade. It's what's happening in that country when they're not engaged at all in international trade. Okay, here's a nice example for letting you see the benefits of trade. Given equal time and labor, Indonesia and Japan can each produce either the number of radios or the pounds of rice listed in the table below. So you want to calculate the nation's opportunity costs for each good and figure out who has a comparative advantage, right? So in Indonesia, the opportunity cost of radios is 2 units of rice, right? And in Japan, it's 1/4. Okay, so this is 1/2, and this is 4. So lower opportunity cost tells us that Japan should be producing the radios and Indonesia should be producing the rice. Okay, so you want to know how to do that, first of all. Okay, and then second, what you do is you actually plot PPCs for the two countries. So if you have them printed out, I would go ahead and do this. I'll just draw it real quick. So in Indonesia, your trade-off is between 50,000 radios and 100,000 rice. Okay, and in Japan, we have 400,000 radios and 100,000 rice. And fortunately, we've already decided where they're going to produce. We've said Japan's going to produce here, and Indonesia is going to produce here, right? They're going to produce according to their comparative advantage, and then they're going to trade. So let's say we make the terms of trade a very simple 1-to-1, okay? Very simple 1-to-1. Will this help Indonesia? Indonesia can now produce 100,000 tons of rice and trade them for how many radios? Well, they can trade them for 100,000 radios, right, if it's 1-to-1 trades. Japan can produce 400,000 radios and trade them for 400,000 tons of rice. We can't even fit it on here, right? So this line, this blue line that I drew, is called the consumption possibilities curve. And you can see that for both countries, the consumption possibilities curve falls above the production possibilities curve, which means that they can get more, better combinations of goods and services by specializing in trading than they could by making all of the goods and services themselves. Except for the pivot points here, this point and this point, except for those, every combination on these blue lines is better than anything they could have done themselves. And that's how we can demonstrate the benefits of trade. All right, can you find comparative advantage if you see a problem that looks like this? Okay, assume it's an output problem. The key here is not to get, freaked out by the different appearance, but just realize this is the same data that's in a table. So nation A can do 100 or 40. So what is the opportunity cost if they produce bicycles? Well, they have to give up 40, right? They give up 40 to get 100. They give up 100 to get 40. Okay? You can solve the rest of that problem and see who has the comparative advantage in bicycles and who has the comparative advantage, in cars. And that is it for our first week of notes.